welcome everybody. We're about to get our session started. And hey, day 3 build, right? Woo! Awesome. All right, so just real quick, just remember, this is going to be a hybrid session, so we do have people joining us virtually as well as we have our attendees here in person. If you just take a quick moment to scan those QR codes on your left and right-hand sides, just to go ahead and join in the Q&A, go ahead and ask your questions there. We also have our expert meetup on the level 5, so definitely stop by there, check out some cool demos and some cool stuff that's up there too. So, all right, without further ado, let's take it away.
Hello, everyone. Hello and welcome. I am Shireesh Thota. I'm Corporate Vice President for Azure Databases. Thank you all for starting your day with us today here. I really hope you had a fantastic build session so far. There's still a lot of great sessions. Let's dive in. Now, there's one concept that has taken center stage of late, certainly this week, and for very good reasons. There's no device, no role or function, no industry that has been untouched from the promise of AI. And this is really important for all of you and for all the organizations that we represent. We at Microsoft have a very important role here to make sure that we're building a platform that is ready. It's going to accompany you for your growth. We want to make sure that our platforms are intelligent, are integrated, and trusted, touch every corner of your data layer. Now, with the arrival of AI, we could certainly question the art of possible. We could question the status quo in terms of what the cloud providers are going to offer you in terms of every aspect of your data, be it the database, the applications that you build on top of the databases, or the analytics that kind of connects it all. So in this session, I'm going to walk you through our vision of what the role of AI is going to be in terms of databases and how Azure databases are built in and tuned for this new era. Let's dive in. The most important thing for us is to ask the right questions, right? So the first one here is, are we building the right features and capabilities for you to go build the Gen AI applications? Features such as performances, simplified data management, and all the goodness of databases, durability, really efficient way of retrieving data. These are all super important. We all know that, and they're table stakes. The database developers do expect that, but they want more than that. They want to make sure that their applications can be seamlessly built, which essentially means that they need to have capabilities such as vector search, RAG design patterns that are deeply built inside the database. So I'm going to walk through some of these examples and some of the services that we are bringing in here. So we'll talk a lot about the first pillar. The second one, briefly, this is the goal of simplifying developer experiences. Databases absolutely should have all the good features that I talked about, but they need to become intelligent in themselves. The database of the future needs to power and empower you basically to do less so that you can go focus on what matters the most for you. You should be spending all your time building the great applications higher up the stack. Databases need to become self-optimized. They need to become self-repairing. They need to become self-secured. Let's walk through these two aspects, two goals that we have here, starting with the first one. How do we power the intelligent applications? So then the question is, what are the key applications that the database is going to really go empower? There's lots of them, but it comes down to these two primitives. Vector search. Vector search is effectively a way for you to ask get similar responses in the semantic search, semantic realm. So you could be asking questions such as, hey, give me this boots of certain color, of certain cut, et cetera, et cetera. These are like specific predicates, specific range filters, and you would get the specific answers. This is an important part of database querying, not going away, absolutely not. We nurture that, we're going to invest in it. But now with vector search, you could ask questions such as, I got these other boots, can you give me something like this, without knowing all these parameters. It figures out all the parameters itself. It does a lot more complicated math on top of it. We'll dive into it in a minute. RAG, on the other hand, is this incredible design pattern that combines the power of a pre-trained large language model like ChatGPT with that of an external data source for enhancing contextually more accurate responses. And since databases are the sources for the enterprise and structured data, they're often invaluable tools in terms of augmenting your responses from the natural language, from the large language models, and factually ground them. These two applications together make up for the most important aspects of the future databases. And let's look into some of these workhorses that make up the vector search here, starting with vector embeddings. Vector embeddings really are the ones that can empower use cases such as RAG patterns, natural language processing, agents, AI search, et cetera, et cetera. Put simply, this is a mechanism for you to go take complex information, audio, video, images, et cetera, and transform them into numerical representation that then can be stored and retrieved efficiently. You can effectively take two pieces of information and basically ask, hey, just tell me the score of similarity between them. And because of this, vector embeddings can help you go build applications such as recommendations, answers, anomaly detection, search, and many more. Vector search then comes on top of vector embeddings and make it possible for you to retrieve relevant information, get the precise search aspect possible. It helps you build applications that can get valuable information between many pieces of the data. The way it does is by connecting the nuances, understanding the dimensionality between these two pieces of data through what we call as vector indexing. And because of the applicability of this, it has to serve the needs of various types. It supports images, audio, video, graphs, sensors, et cetera, et cetera. And it goes much farther than the usual keyword search. It enables your application to run similarity queries so that you could basically go do more than just the term-by-term mapping. And given all this stuff, it really helps developers build applications that can give you natural responses in the natural language. It can identify patterns. It can help you detect fraud detection, many such things. And RAG, I touched upon it briefly. It's, again, a very important design pattern. Let me spend a few minutes here about RAG. It basically can help you offset the limitations of large language models. The way it does is by helping you customize, improving the performance, without you having to retrain on new data, without you having to fine-tune, which both are time expensive and costly. And you don't need to do all that stuff when you combine your data with RAG. It helps you avoid misleading information, inaccurate responses, because it factually grounds the response in some contextual information. Let's take an example. If you're basically going up to an application and sending a prompt, the application can directly send the prompt to the large language model like ChatGPT. If it does that, most of the times, if you're asking for some specific information that may not be available for a large language model, the response is not going to be that great. Instead, application can send that prompt first to a database where there is contextual information for that prompt. Now, the database, thankfully, has vector indexing in it, like Azure Managed Databases, so it can retrieve the right information for you, send it to the application. The application can then augment the prompt that the user gave with the information that it got from the database. Now, take this augmented prompt and then send it to the large language model like ChatGPT. Your responses are going to be a lot more accurate. Imagine an employee in a private company asking questions about their benefits. Now, if that query directly goes to ChatGPT, the odds are that ChatGPT has no idea about your private company's private benefits information. It's not trained on that. It doesn't know it, right? Instead, you build an application that basically combines the power of your local database, whether you're using any of Azure Managed Databases, SQL, Cosmos, Postgres, MySQL, et cetera. It combines that power, augments the prompt, and then sends it to the ChatGPT. You're going to get a lot better answers. So all these cool things, the vector search, vector embeddings, RAG, et cetera, they're all going to come together to build the next generation of applications. And I'm excited to talk about how Azure databases are really answering the call to get these features in your hands. Earlier this week, I have walked you through about our vision of Azure Managed Databases. If you were there in that session, you have seen this. We were talking about how Azure databases are going to be built in and tuned for generative AI applications with hyperscale performances. We're going to have copilots to boost your productivity. Our managed databases are going to do a lot more on your behalf. If you have investments and experiences in on-prem, they need to seamlessly scale to the cloud. All that is possible because of our intelligent databases. They're going to be integrated because we'll have a ton of fabric integrations. You can harness all that power to focus on innovation. You can trust our platform because we have unprecedented privacy, security, sustainability guarantees. All this will help you go really power your applications of the future. Now, here, I'm going to pivot a little bit and walk you through some of our core databases and how they're helping you build these new applications. Let's start with Cosmos DB. Azure Cosmos DB is our flagship NoSQL database. How many of you have used or played with Cosmos DB so far? Okay, quite a lot. Well, thank you. Last month, we have run our 4th worldwide annual conference. This is a virtual event where we had 12,000 views across the globe from a growing community of developers who are building their new apps powered with AI and Azure Cosmos DB. I'm beyond thrilled to announce that the vector search capabilities are coming to Azure Cosmos DB's NoSQL API. We did announce it. It's in public preview since Tuesday. And it is possible because we brought in the state-of-the-art, very powerful algorithms known as DiskANN. I'm going to dive in a little bit about DiskANN, so bear with me a little bit technical here. To start with, what we are doing here is to bring the transactional data and vector data together in one simplified data engine, just Cosmos DB here. By doing so, we are massively reducing the complexity of building an intelligent applications. This is going to be low cost. It's actually going to be super intuitive for you because you're not dealing with lots of different engines. And it's not just about combining the data. We're actually combining the power of different engines and index engines and query engines. For that matter, you could use Azure Cosmos DB's ability to filter on equality, ranges, and even spatial filters for that matter, a completely different index, in conjunction with the vector indexing. Because you could do these kinds of filters, these hybrid queries, what we call as, you could absolutely go work on really large, massive data sets. And to make it easier for you, you probably have different kinds of knobs, different kinds of requirements. So we have indexing that is a lot more flexible. You could index with absolutely exact queries, like don't want approximations here, want exact, we got that. If you want to quantize before doing the exact queries, and I'll touch upon quantize in a minute, it's effectively a way to compress. So you'll get some really fast answers, and then you can sort, re-rank again. We got that. All the way to a very scalable solution such as DiskANN. So we got different knobs here. I highly encourage you to go check it out. The great thing about all this stuff is that this is working on top of everything that you care and love about Azure Cosmos DB. Azure Cosmos DB, as you all know, has industry-leading SLAs, single-digit millisecond latencies, financially backed throughput guarantees, and high availability up to 5 nines. Everything that I talked about is working in conjunction with all the goodness that we have here. In fact, we're not just focused on the large-scale workloads. We're also bringing this to your serverless workloads as well. And this is all possible because Microsoft Research and Azure Cosmos DB and all our Azure managed databases, we're all collaborating together to bring the state-of-the-art, powerful set of algorithms known as DiskANN. This is going to give you some amazing characteristics across recall, latency, cost, robustness to changes, and scalability. The quick gist of DiskANN is that it's just building a graph index for you, where the compressed vectors are in memory, the full fidelity graph is in SSD. And hence, a vector search effectively becomes a graph traversal problem. So the notion of graph index here brings in a lot of cool advantages, as the slide calls out here. It has high accuracy because we have what we call as directionally diverse edges in the graph. So we can go and find the accurate information. We, in fact, search for the compressed data in memory. And then for accuracy, we re-rank them on the high fidelity graph in the SSDs. It has low latency because in the graph, we store both the short edges as well as the long edges so that we converge faster. And the number of hops that you need to get to the answer is much lower. So it gives you low latency. And since compressed data is in memory, we're not as memory bound like other state-of-the-art vector indexings that are out there right now. That makes the cost of doing vector indexing much cheaper. Better yet, it's going to do that at scale because the full index is actually on the disk. You don't pay and you're not constrained by the memory challenges that you typically have to if you go to the other indexes. All the full index is on disk. And of course, everything about Azure Cosmos DB is about elasticity. And now, vector indexing is going to go in conjunction with that property. So that's why it's one of the most scalable, most highly available, awesome accuracy and low latency vector index that's out there. It's industry first. And the great news here is that DiskANN is not new in Microsoft. We've been basically incorporating it into many of our products. Bing, for instance, has been using it in a family of offers. It uses almost 400 billion vectors with trillions of points in the graph. Uses it for its accuracy and latency promises. It's also used in our M365 applications, such as Outlook, SharePoint, even Teams. A little bit deep dive into the how part. There is a property called quantization. I referred to that a moment ago. Quantization, effectively, think of it as like you have these large vectors. If you all used OpenAI, you probably know that it has 1536 embeddings for any vector. That's a large data point. It's almost 6K. If you put all that data in memory, it's really hard. It's going to be memory constrained. So what we do here is there is a property called quantization where it compresses. It reduces the dimensions into groups, where each group effectively has equal number of points, approximately equal number of points. And because these compressed data points are in memory, it's easier and faster to go search them, while making sure that the full truth is still on SSDs. There's a family of algorithms here that are working here to make the optimal search possible. 𝗲𝗲 is the biggest one here. It has a property called building a relative neighborhood graph that takes the most relevant edges. It just takes the most relevant edges for you to go search instead of just completely spanning the whole thing. And that makes the search super optimal. The pruning algorithms over there will help create an optimal graph in what is called as a low diameter graph. And if you're interested, want to deep dive more into this, there's a lot of literature about DiskANN there. There's lots of good papers that research team has published here. This is truly one of the most important vector indexing that's out there, has the best recall capabilities. And perhaps this is really my favorite feature of DiskANN. Often what happens is that as you keep inserting and deleting in the vector indexes, the recall regresses significantly. As you've seen, HNSW in this case just went down massively as the insertions and deletions happen. And this is bad because you have to now reindex. The efficiency of that goes down. It shows up in your latency. It shows up in the accuracy, et cetera. Not with DiskANN. It continues to have the same recall. And that's because of all the powerful set of algorithms that we brought in here. So that, in essence, is really what I wanted to present about DiskANN. It is today with Azure Cosmos DB. We're going to bring it to all Azure managed databases, but this is in public preview today. So I highly encourage you, request you to go play with this. The next announcements that I want to talk about with Cosmos DB is the integration into frameworks such as semantic kernel, .NET and Python, and large language model, Python and Java. Semantic kernel and LangChain are frameworks that basically helps you go build these applications in conjunction, playing with LLMs. LangChain is an open source model that is, of course, thriving on the committers and tools and integrations that are out there in the open source community. Today, you have it now with Azure Cosmos DB for NoSQL as well. Semantic kernel, on the other hand, is a lightweight framework that was built by Microsoft. If you're looking for something simple and efficient, semantic kernel is definitely worth the consideration here. Again, vector search, all the integrations are going to help you build applications super easy. Go check it out. And by the way, all these frameworks are going to be available for all the other databases as well. In fact, LangChain has integrations to open source databases, PostgreSQL, MySQL. SQLDB already has connections to semantic kernel. We're going to bring LangChain as well pretty soon. So this is all about Azure Cosmos DB. Let me switch gears and talk about another database here, Azure Database for PostgreSQL. Now, this is one of the most popular open source databases out there, really rapidly being adopted. And it is one of the most front and center for application developers because the community has been investing quite a lot. It already has a natural way of storing and retrieving vectors through what we call as PG vector extension. And we are contributing quite a lot here. In fact, if you don't know, Microsoft does quite a bit here in terms of our contributions to the open source database. Thrilled to announce the in-database embeddings generation for Azure Database for PostgreSQL. With this, we are bringing the Microsoft's open source E5 text small model and embed it inside the engine so you could execute for getting the embeddings locally within the database. You don't have to make a call to an external model like OpenAI or any other model. You could do that. There are slightly different kind of accuracy, latency trade-offs. But since the embeddings are local, you'd get really great latency, single-digit millisecond latency for you to generate these embeddings because they're all being generated locally. It's all packaged inside of Azure Database for PostgreSQL here, so you get predictable cost and very high throughput. And finally, You could keep the data compliant. You're not moving anything outside the database, so you can bring in something that requires you to have private or highly confidential information. So that is announcing today. And if you are aware, PG has this extension called PG Vector. I referred to it earlier. It has a way to store and retrieve indexes, vector indexes locally. Great news is that the local embeddings that I just mentioned works in conjunction with this extension. So you could continue to use PG vectors to store and retrieve vectors while you use the local embeddings that can help you generate the embeddings that then can be stored into the vector type using PG vector. And we support various indexes. This is, thanks to the power of OSS community here, we support inverted file index, IVF flat index. This is good when you basically have some limited data points, something like, let's say, 1 million data points. And often when the data points are not changing often, you're not doing too many insertions, et cetera, this is a great option. It has amazing memory and speed characteristics. It basically partitions the data into different clusters and then tries to help you get to the query fast. On the other hand, we also support HNSW. Hierarchical, navigable small words, it's a mouthful. The way that this data structure works is very similar to skip list. If you remember skip list from the other side of the world, in the databases world. It has different layers where the graph is laid out on each layer, edges are in that layer as well as across the layers effectively. If you have more than a finite kind of data points, if you're trying to do more CRUD, more inserts, deletes, et cetera, it has slightly different characteristics than IVF flat, but it is also a pretty efficient index. It's one of the most popular ones out there today, but they all have some limitations. As I said, recall is one of them that I mentioned here. Hence, we are bringing all the power of DiskANN that I mentioned a while ago to Azure Database for PostgreSQL. And this is the goodness of basically betting on Microsoft and Azure databases, because we bring in the best of our Microsoft research to all our managed databases. We're going to commit this to Postgres as well. This is coming before the end of summer, just few more months. It's coming to Azure Database for PostgreSQL. We are super committed to making sure that this comes to SQL and MySQL databases as well. And to show all this goodness, to show how all this works in PostgreSQL, I'm going to call onto stage 𝗦𝗲𝗀𝗀𝗀, our product leader, who's going to show how all this cool work is coming into action. Charles, please take it away.
Thanks, Shireesh. Morning, everybody. So my name's 𝗦𝗲𝗀𝗀𝗀𝗀, and today I'd like to show you how the new local embeddings in Postgres enable you to build incredibly interactive applications for vector search on Postgres that can then power those RAG-based applications that Shireesh mentioned. So I'm going to start in a basic web app. This is a travel site, and effectively what I'm doing here is I'm using search, as we're all familiar with search engines, to find somewhere that I'd like to stay. So I'm going to go and search for somewhere that allows small dogs, because I'm traveling with my pet. And if I go run this search, it's going to take a little while to return the 90-odd results. It's not bad, but it's not the interactive experience that we'd expect. Let me show you how it's built today on Postgres and how you can now build it using the local embeddings and the performance that provides. So here I am in my favorite Postgres editor, pgadmin, and I'm going to go ahead and run a simple select query. I'm taking 4 columns, and this order by clause is really important. This is where I'm invoking the Azure AI model that's making a remote call. There are 384 dimensions, and this single query comes back in about 45, 46 milliseconds, right? So it's not too bad, but we can do better because we're running a SQL query where we expect really fast performance, but we're making a call to a remote service. So let's zoom out again, and now I'll show you how the new local embeddings can work to make these applications really quick. Same 4 columns. The subtle difference is that Azure Local AI in the order by clause. So I'll go ahead and run this. And what's happening is that allows small dogs text that I put in my search is being converted in the database to an embedding that I can then do the comparison against all of the data in my database. Like Shireesh mentioned, this is where we're using your enterprise data. Think about all the applications you run that have got embeddings created for them in each row to go do a similarity search using vector comparisons. But to do that, I had to create the vector first for the search that I put in. And you need to do this for every different search that you run. That's exactly what's happening here. And now that query is down to about 4 milliseconds. But we really want to test this at scale. So let's go and run now my remote embeddings in the left-hand side and the local embeddings in the right-hand side, as you can see here. And so what I'll do is we'll kick this off on the left-hand side to run a series of transactions. And because we're making these calls out to a remote service, we're only able to sustain around about 15 to 20 transactions per second out of the database. The right-hand side is already finished. We asked it to run 800 queries, and it ran all of them in a little over 3 seconds with a sustained rate of about 242 transactions per second. That's the performance of running locally in Postgres. The left one ultimately finished, and you can see the average latencies there. Now, the important thing about this performance is that data is always changing as well. And if the data that I'm changing is based on the embedding I've created, I need to recreate the embedding as well. So here's a standard simple SQL statement that's going to run an update for where I may have added new product reviews or changed the description of a product text. And I can create those 5 embeddings faster than I could create a single remote embedding. Now, remote embeddings are no less powerful because of the latency. They provide greater flexibility for all of the models that are available in Azure AI services. But as Shireesh mentioned at Build, we're now shipping Microsoft's E5 model locally in Postgres out of the box, and it just works for running SQL queries like this. Now, if I come back to my app and we go and run those small dog search again, it's effectively instantaneous. We've localized the embedding creation and comparison, and now we can go power those LLMs with the context of our data to give you a really rich and interactive response. Thank you, everybody. Back to you, Shireesh.
Well, thank you, Charles. I want to move on a little bit to other announcements here. So we are bringing in index recommendation for Azure Database for PostgreSQL. Indexing, of course, super important. It's really essential for performances. As time goes by, as cardinality of your data changes, your schema changes, etc., it's often really hard to keep up with the accuracy of the indexing. So we are bringing in support for automatically understanding all your query workloads and detecting what needs to happen to make sure that your workload has the right indexes. Sometimes you have to create new indexes. Sometimes you have to drop some indexes. Obviously, it's a tax for insertions. So we take care of all this stuff. We even tell you which queries are going to be impacted. Can even forecast the performance improvements for this. So this is all what I wanted to talk about in terms of powering the intelligent applications. I want to move on to the next pillar and talk a little bit about how we are doing in terms of simplifying the developer experience. Here, we're going to bring the power of Azure OpenAI Service, Azure Machine Learning, and Copilots to streamline the experience for your developers, to make sure that your developers and database administrators can focus more and more on top of the stack. We are very comfortable in databases taking the backstage. We want to be the database to be the humble sort of supporter from behind and let the app take the center stage. And that is really the promise of what we are trying to do here. And we have lots of announcements in this direction. Azure Database for Postgres' Azure AI extension is going generally available. This is something that we've shipped at Ignite. This enables you to have cool integrations with a broad array of all of the Azure AI services. Azure OpenAI, Azure Machine Learning, AI Language, AI Translator. There's a consistent, a simplified interface to be invoked from within the SQL functions of PostgreSQL. Because of this, you could basically go generate rich generative AI experiences for your PostgreSQL workflows and applications. Now let's talk a little bit about copilots. I know you've been waiting for copilots. There's lots of copilots here, and we want to bring it all to our databases. Copilots, we believe, are going to be very important to make sure that we can help you build applications that have dynamic scale. They need to make sure that they have intelligence built in so that you're productive. They will enable you to have great automation to do data management. And all our databases are going to have lots of Copilot capabilities, starting with Azure Database, Azure SQL Database here. And here, Azure SQL Database is bringing in the power of copilots in 2 form factors. One is in the chat window. The second is natural language to query language. Let's dive in a little bit here. The chat window, you could totally ask and receive helpful contextual information inside the context of the Azure Portal Blade. And you could ask questions such as, hey, give me the size of my SQL database. Give me the active connections. Give me, in fact, what were the most resource-consuming queries just last week. You could open up the chat window, in the context of the database that you're operating in, and just start asking questions such as, why is my database slow today? We want the Copilot to be collaborative. We want it to be working in conjunction with you to make sure that you could gather insights and troubleshoot them. The great news is that this Copilot works in the context of the database that you've opened the portal blade, and it obviously understands what's happening with the database and starts enumerating lots of details for you to go work on. Great news, it works within the confines of the permissions that you have. We obviously take security very seriously. We don't want you to exfiltrate unnecessary information, so this is pretty safe. A natural language to query, again, we want you to be able to interoperate with the SQL database intuitively with natural language queries. So we're going to take care of understanding your table schemas, column names, your primary keys, foreign keys, and all kinds of metadata, and generate highly accurate information. You can look at it, you can edit if you want to, and then execute it. And it's not just for some simple queries. We're doing it to make sure that we support really complicated ones. Things such as multi-table joins, aggregates, pivot tables, CTEs. All those kinds of things are going to be possible because of all the cool things that we are doing with the Copilots in SQL Database. To show more of this, I'm going to call onto stage a star architect, Bob Ward. Bob, please take it away.
Thanks, Shireesh. Thank you, Shireesh. Folks, some time ago, our data science team and the SQL team said, Bob, we're going to build a Copilot. You've been around for a while. What do you think we should do for self-help? I said, hey, for decades, we have rich telemetry built into the SQL engine for performance, for everything you need, and you can run SQL queries on top of it. So why don't you start with that? And they're like, that sounds pretty cool. So we spent time taking in what we call Bob in the box, putting inside, in the Copilot, a deep set of knowledge of how to tackle really complex problems. And the team said to me some time ago, hey, why don't you take a look at it? So I'm going to show you what it looks like. So first of all, what I told the team was, what can this thing do? So I'm in the context of my database. That's what I love about this whole thing. I'm in a natural thing in the portal here in the context of my database, and I'm asking, what is it possible that you can do as an actual Copilot? So I'm going to ask this question, what can you actually do? So in the chat window, I'm just going to say, what things can you do to help me with my database? I'm actually using a hyperscale database, which you can start, a very great way to start your database to scale up. And Copilot's going to actually tell me specific things it can do to help me in the context of the database I've deployed. Now, what I love about the top list here is these two areas: troubleshooting and diagnostics and performance tuning. Things that are very, very difficult to do for a lot of customers, developers, even really expert DBAs. So the team said to me, what's the litmus test for this? And I said, well, if I can take a performance problem, which they didn't tell me what it was, and I can ask Copilot something very vague. This is the promise of Gen AI. My database is slow. Who can do this today in a very, very fast way? We've got all the telemetry in the engine, but you've got to know how to go navigate all that. So Copilot is going in and looking at, based on your permissions, things you can look at yourself but may be difficult to navigate, and it already knows, hey, you've got a high CPU problem here. And by the way, it's been going on for a while, and I'm like, okay, well, that's great. What's the next step? Well, probably I need to figure out what query is involved. Everybody wants to know what's the query as part of it. So I can kind of scroll down and say, yeah, you know what? I can actually tell you the query. Well, this is great. I'm already on the path to figuring out what the problem is. So what typically happens in those high CPU scenarios is maybe I'm missing an index. So instead of actioning the Copilot, it's already prompted me and said, hey, maybe I can help you optimize this query. So I'll just click this prompted button here already and say, let's see what you have. Sure enough, it can go look at inside the telemetry in what we call the query store and say, you know what? As it turns out, there is an index you could be using. So it's already told me, hey, here's the query, here's the actual index you could use, solving a problem in minutes that could take hours. So then the team said, well, what else can you do? And I said, well, there's other types of performance problems where the database is slow that are not as obvious. And I'm like, okay, well, I'm going to ask the same question in a different scenario. Hey, my database is slow. And, I'm like, okay, I'll wait and see what Copilot has to say. Now, at this point, I still don't know what's going on. Maybe it's the same high CPU problem, or maybe it's something what I call a waiting problem. So in here, the Copilot has already determined, hey, you know what? There's not a CPU issue going on. But as you scroll down, it said, you know what I detected, though? I detected a blocking chain. And it's like, I can even tell you the specific sessions in SQL that are causing the blocking and the query that is part of this. Now, I know performance troubleshooting a little bit, and I'm testing the system. I'm like, okay, well, I got the blocking chain. And maybe in this scenario, which is very common for applications, it's got a transaction open. So it said session 110 was my problem. So again, I'm having a conversation with this Copilot based on my telemetry saying, hey, is session 110, does it have an open transaction? I asked this question. Copilot can go look at, again, this telemetry based on what's in SQL already and say, as it turns out, there is a session that has an open transaction. I want to go deeper, even what Copilot's telling me. So I'm going to use what I call my performant in the cloud, database watcher, something that's in public preview today. It's storing data in a Custo database, which I can get deep information in dashboards or even in the Microsoft Fabric. So I'm using the actual dashboard scenario here going, hey, why don't you tell me over the last 15 minutes, what does the activity look like and what's blocking? Look at the deep information I already have from Watcher. I can see in here now the blocking chain. I can see the lead blocker. I can scroll over and see what is being blocked. And then I can kind of scroll to the right and get more deep information like, as it turns out, there is open transactions here I need to deal with, or even other telemetry like, what's the program name? Who's the user involved? This is really powerful stuff. Here's the thing. It's happening right now, but maybe what happened in the past? Like, is this a pattern that's going on? Watcher stores historical information even for blocking problems. So I'm going to go up here and say, what's happening over the last, say, 4 hours? So I'll go historical mode, pick the last 4-hour window, and see what I get. Look at this. It said, oh, no, there wasn't a blocking plane just now. There was a blocking chain several hours ago. I can then go into the graph historically, drill into it, and see the same blocking problems occurring. I'm telling you right now, this is a problem that no one can solve today. Usually they have a problem that's happening, a blocking problem. Yeah, there you go, thank you. Not me, it's the team that built it. Because normally people have a blocking problem, but they don't know what happened in the past. The combination of Copilot and Watcher gave it to me. So this is a fun one, and it's a fun database name. The team said, okay, we're going to stump you on this one, Bob. We're not going to tell you even what's going on here. Don't say slow. I'm like, all right, can I detect there's any problems with this thing? Copilot, just look and see, is there anything you notice about the scenario? So Copilot's going to go in and use the same pattern of looking at running versus waiting issues. Again, this is something that I would do today if somebody asked me about a problem with my database. It turns out there is a CPU problem here. I'm like, okay, team, nice try trying to stump me. It's the same thing before. It's probably missing an index or something like that. So I'm looking down here, and it's looking at okay, no problem. But it's telling me the query. I know the query's going on. I'm like, okay, you know what I love? I can click this button and see what it's doing. So now I've got insights to what the Copilot's doing, so I know behind the scenes based on my permissions, using that deep telemetry, what is it doing to try to go and solve these problems? Any Copilot answer has the ability to see the insights of what it's doing behind the scenes. So, okay, fine. Try to go optimize my query for me. I'll click this option like I did before, and I'm like, okay, it's got to be probably a missing index again. There's something called an anti-pattern query. That's probably what the problem is. So I'm looking down Copilot's like, as it turns out, there are no missing indexes in this query, and I've detected and looked at your queries. There is no anti-pattern problems here. So I'm like, maybe they have stumped me. You know what, though? Maybe it's tuned, but I'm hitting a resource limit in Azure. So I'm going to go like, hey, Copilot, do I have any resource limit issues going on? So we'll ask this question again in a very natural language way. The telemetry's all there to tell us this. So Copilot's like, you know what? I'll take a look at your question and look to see what is your current CPU configuration and what does the CPU should look like based on that. Sure enough, it's saying, you know what? You're tuned. You're just hitting a limit. This is incredible. I mean, to be able to go in and do this today takes an incredible amount of time. So I've shown you 3 scenarios where something that takes hours or even a support call to Microsoft can be solved at minutes using the built-in rich telemetry of SQL. So we talked about natural language to SQL. And you know what? I've been writing SQL queries for a while. But one thing that's difficult for some people writing SQL is to do hierarchy navigation of your relational database. So I went into Copilot in the query editor and said, can you give me a hierarchy of product levels in my database? Now, here's what we do in natural language. You pick your tables, the schema that we're going to feed the model. I'll pick all of them. We know the names of the columns, the tables, and even the key relationships to build joins for you. So here, I'm going to accept what Copilot's doing. And here, inside the editor, it's giving me comments to show me what did it actually try to generate. So I can scroll down and look and see, oh, it's using what's called a recursive common table expression. Even some of the deepest experts in the world for SQL don't know how to write queries like that. So now, with Copilot, I have generated a query that can be very complex to do in a very accurate and performant way. When it's done, I can finish it and run it. What an amazing system. So now even people that don't know how to write complex T-SQL queries can use Copilot to do that. Shireesh, what do you think, man?
So it's super cool.
Yeah.
Super cool, Bob.
Yeah.
So we didn't manage to stump you. But
Yeah.
how many years have you been in SQL business? How many years have you been running
like 30,
queries?
almost 31 years.
31 years, and you still can't write recursive CTEs.
Oh, man, that was rough. That was rough. That was rough, man. That was rough.
Well, everybody needs Copilot. Even Bob needs Copilot. But thank you, Bob. I want to call on a few other announcements here. There's obviously you probably have seen Azure Cosmos DB Copilots. It's been in public previews, lots of great usages. We're going to refresh them to get a lot more other capabilities. The one thing that I wanted to just call out about these Copilots is that we build all our Copilots with our stringent principles of responsible AI at Microsoft. We want to make sure that we are not just giving you accurate information. We want to ensure that they are coming in with the right security guardrails, with the privacy and all the security assurances that Microsoft has. And of course, SQL Copilot that Bob showed, Cosmos DB one, and everything that we build are all built with those principles in mind. We want to make sure that with Azure Cosmos DB, we can optimize your queries really, really well, reduce your latencies, make sure that you have the right configurations. And then the natural language to query language, Azure Cosmos DB also has one. It's available inside the Data Explorer. It's free, by the way. You should really use it. It's super easy to intuitively operate with natural language and get to NoSQL queries, just like the T-SQL queries that Bob showed. So those are all available. We are looking to refresh them to move into the Copilot in Azure. So we are trying to streamline and simplify the gazillion Copilots that we have today. We're also announcing Copilot capabilities in Azure Database for MySQL. And this is cool. We basically have an ability for you to interoperate with the public documentation. It can be daunting sometimes to just look at the documentation and troubleshoot issues. So this will enable your application developer to understand the content all the way from Microsoft's the learn content, best practices, et cetera, and troubleshoot issues easily. So this is all about the Copilots that we have here. And I want to just quickly summarize everything that we are announcing here. There's quite a lot here. We have Azure Database for PostgreSQL's AI extension. Bob, I need to finish.
No, I forgot to show you something. I forgot to show something.
Okay.
We built a Copilot for SQL Server.
Are you trying to stump me?
I'm trying to stump you. Yeah. So we forgot to tell you, we built a Copilot for SQL Server.
Really? And I mean, I know that, but you're going to show it now?
I'm going to show it now. Can I do it?
Okay.
Yeah, I just want to show you. Yeah,
Okay,
yeah.
gotta do
People have
it
been
soon.
asking for this, right?
Okay.
So yeah. Here's a first look.
Well, I'm going to hang in and see it.
Yeah, a first look at a Copilot for SQL Server.
Yeah.
Shireesh, I'm connected with Azure Arc for SQL. I've got a bunch of SQL Server on-premise instances connected with Azure Arc. I want Copilot to help me get rich information about my instances. So I can just ask it, what's the inventory of instances you have? Now, I don't want to just get the list of SQL servers. I want it to give me insights, the promise of Gen AI on actions to take. So here's all my SQL servers, additions, versions, et cetera. But what's interesting about them? Well, number one of these instances, Shireesh, is running SQL 16, but is missing a security update. So it already knows, based on what I'm configured, you need to take some action. The second one, 2014, it's running out of support. So now I've got insights here. Hey, you may need to go actually do something about what's happening with this instance. That's interesting. What about resource utilization? So again, this is running on premises, but using the telemetry of Azure Arc, I can go to Copilot and say, what does my resource utilization look like for this SQL server on premise here? Copilot can go look at the basic telemetry and say, well, as it turns out, you don't really have a lot of CPU utilization going here. Well, this doesn't make any sense to me. I'm like, this is a very active SQL server. I think it should have something happening in the system. Now, remember before I showed you about performance, about my database is slow? I wonder if there's any kind of weighting problems. A lot of SQL experts, what they do is they go in and say, what does my weight stats look like? So I go to Copilot and say, hey, do I have slow weight stats going on this instance? Again, this is a SQL server on premises. But I'm using Arc with Copilot to look at it. It's like, you know, it turns out you do. It's giving me a list of weights that are happening in the system. And any SQL person, when they see LCK, that's a blocking problem. So now I know with telemetry in a very, very quick amount of time how to go tackle a problem. And the final scenario, again, just a first look here, Shireesh, not preview yet, but it's coming, is about HADR. So I don't know, when's the last time I've had a log backup for this database? Kind of important, right, to my database. So it can go in and just quickly look at telemetry and say, hey, there's a log backup that has been taken here. That's a long time ago. You better go do something about it. And finally, availability groups. They're great technology, but often sometimes hard to manage and detect the health for them. So I'm going to go to Copilot and say, hey, what does my AG look like? I've got an AG for this system. And again, notice I'm not asking about the health of the AG. I'm just saying, what do I have as an AG? Copilot's going to give me extra insights to say, it's not synchronized, it's not healthy. So Shireesh, it's all about making sure we can help administrators manage their SQL estate and not just give them information, but take insights on it. So sorry to interrupt you, but there it is.
That's super cool. You know, one of the things that we see.
More coming.
Yeah, and this is the most important question that I get all the time from the customers, like all of you here. You know, when is it coming to SQL Server? We absolutely love and care about SQL Server. We're making sure that Gen AI, we're not leaving behind SQL Server. So this is a great example. Thank you.
Thanks, Shireesh. Thank you. Yeah, sorry to interrupt you.
Thank you, Bob. Yeah, so I lost my thought here a little bit. But, you know, I just wanted to thank you all here. This is a great summary of everything that we've done here in terms of Copilots, the vector indexing, enabling you to go build RAG design patterns across all our databases. It's a new era. It's a super exciting time. So on behalf of Microsoft, on behalf of all my team, I thank you all for starting your day with us today. I really hope you walk out as excited as we are in terms of bringing AI into Azure Managed Databases. There's lots of pointers here, some get started in skill ups. There's still some really good sessions left. Scandinavian Airlines, for instance, 170, they're coming in today and to talk about their use case. Highly recommend. There's PostgreSQL sessions. There's a lot of other database sessions. I hope you enjoy them all. Thank you so much. Enjoy the rest of the conference. Thank you for attending today.